Hi, I was going to just introduce some of the um, electrical part of the robot and uh, some of the main way that we figure out what needs to be on the robot is just by what's specified in the rules and what's allowed. And so, for that reason, I'm going to kind of go and look at the manual. So, here I just searched for first robotic manual, and this brought up Rapid React, which is this year's. And it breaks it down into lots of parts of the manual. The electrical part, uh, actually, it's not the part that most of the time we read in detail during the year because usually it doesn't change a lot. So usually, if you read what it says now, it's going to be 90-95% the same, or maybe even more. So, but it's under this robot construction rules, and this is like 38 pages. So the rule book itself is probably, I don't know, 100 or 150 pages. Um, and just the construction rules is 38 of those pages. And there's really no kind of guide of where things are in the construction rules, but it has section headers. So, like this first one is general robot design, and then the rules all mostly have a number and then kind of a headline and then the rule, and then anything inside like blue boxes is just trying to uh, explain the rule, uh, which is the part above. So um, for electrical, we're on a smaller part, so that's, I think it started around page 17. So I'm going to come down. There's frame rules, rules for, well, actually, I'll start up here. Um, the first one that really kind of starts to be electrical is the motors and actuators. And so this is on, yeah, page 17. Um, this tells you all the motors and their parts that are allowed on the robot, and says any quantity. Uh, Now, I made a little shorter thing here, just a condensed rules I was trying to come up with. So the motors that you have are the Neo 550, which is a kind of a 550 is the size of a motor, so 775 is a larger motor, and 550 is a small motor. Uh, we don't have any of these, but we could use them. They're brushless and pretty fast. Um, we've used the red line and the Neos this year. Uh, Other teams like these Falcon 500 motors, which is a motor plus a controller. We've kind of went the other way, but it's not something. It's something we could use again. There's automotive motors and other things on that previous list, but we just haven't. We don't use a lot of them. And there's also here, if I go on the list, it shows you some of the electrical solenoids, uh, fans, hard drive motors, any of this sort of stuff, compressor. Uh, but so that's the loud motors, and then the next one is just not to modify motors. So you can cut the wire and you can do a few things, but you can't really change. You can't rewind it or do something that might give you an advantage. Um, the power uh, is provided by some sort of motor controller. In this case, it specifies a bunch. Really, on here, we only use the F, which is the Spark Max motor controller. This can do brushed or brushless, so it has a lot of flexibility, and it's also well, they're not the cheapest because they have the brushless part, but they're like $80 a piece, I think, right now. But they're also smart controllers, so they can limit the current and do some other things if you need to use that in the programming. Relays, we don't really use too many relays, but it's a possibility. Also for controlling pneumatics. This next rule is don't overload the controllers. It's just saying how many motors are allowed per controller. Generally the answer is 1, but there's a few motors that are small enough that they allow you to put 2 motors per controller. The brushless motors, since they don't they have to have the feedback, they don't work with just having 2 motors per controller. It can be handy. We don't really, like I said, there's not as many motors these days that the brush motors that are useful for 2 controllers, but at some point that was useful because you could control, like if you needed 2 motors for a roller or something like this, you could do that pretty easily. Control the servo safely. There's only certain things you can use servos, so servo power module is probably the main one, but you can also control right off the RoboRio, which is the computer, or this other unit. So that's just to provide power to servos. I didn't mention above, servos, you're allowed up to a servo that's up to $75. Maybe that will go up since the prices are going to be a little different, but generally you're allowed 75 for servos, and any single component, I think you're allowed $500 right now, but that may go up too, I'm not sure. And there's no upper limit on robot price anymore. There used to be. So now we're on to 9.6, which is all about the power distribution. Each robot has just a single battery specified to have a certain amount of power. That just kind of keeps everything the same for all the teams. There are just some other small batteries, like you could have a battery pack, or for maybe if you put a camera on, like if you had a GoPro camera you want on the robot or something, but it can't be a very big battery. And you have to, so this talks about a little bit about the battery connectors. They use Anderson SB, there's an SB50 and SB120. The batteries have to charge with less than 6 amps. So we have our chargers are less than 6 amps. The batteries, you can't put an extra battery just as a weight on the robot. People have tried to do that in the past. It's not very smart, and you need to secure the battery with straps, and so it can't move around. You also need to insulate cover all the electrical connections of the battery, and then R608 talks about just other sources of energy on the robot, like springs or pneumatics, and just says that they're allowed, but there may be other sources of energy that, like you can't have a nuclear reactor or something, or a chemical energy other than the battery. And 609, this talks about just having a breaker, settable breaker that's 120 amp breaker. This is a specified, like a lot of the parts of the robot for electrical. In some ways, this is done to kind of ease inspection, to make it easier for students not to have to figure all this out, and also for safety, to prevent bad practices that might cause fires or other things. So there's 2 allowable distribution boards, and the connector from the battery to the robot has to be this SB connector, Anderson SB connector. And there's, well, generally we get some, but there's also PowerWorks or some other places, DigiKey, that sell, or other suppliers that sell these kind of connectors. So all the distribution boards have breakers and a few fuses, and you're only allowed to put 1 breaker per circuit. And then R611 is you can't ground to the robot, so they'll check and make sure there's no that the resistance between the battery terminal or the terminal of the robot and the frame is low enough, and that you don't have any current that could be going through the frame. You must be able to turn off the robot on and off safely. That means just that the breaker, that's the button, it's got to be close enough to the edge. And this is handy in case the robot runs away or something, that if you can get to the edge, you can reset it. The electrical, so this is the kind of the wires and the distribution have to be inspectable, and that only is important during the inspection. So it can you can have the distribution board kind of underneath or at the bottom of your robot, underneath stuff, but you have to just keep in mind that the inspectors will want to see it. And so you might have something, you might have a plate that hinges away, kind of like we had on this year's robot, or other ways that you can show the wiring to the inspector. And that rule's pretty loose as far as it doesn't exactly say what it means, but if you hid your power distribution board inside the robot, then they probably would make you do something to make it visible. There's no high voltage, so no voltage over 24 volts. The battery's 12 volts, so you could have a step up to 24 volts. I don't know if that's, I think that's, oh yeah, that if you did that, that's a custom circuit. So you can't run a motor controller off 24 volts. That's another rule. But, you power the RoboRio and also the radio from the power distribution, and they have kind of specified pathways for that. So there's a fused connector on one of the boards, or both the boards, in kind of specified places. For the radio, it's the same. You can either power it from this voltage regulator, or from a different voltage regulator that's a bridge, an Ethernet, power over Ethernet bridge. I think I had a picture. Just I come up here. So this is the radio power module. So you can power it this way. The only 1 wire per terminal, so you can't put multiple wires, and you can only use these snap action, or last year Rev Robotics made some 40 amp or 30 amp and 20 amp breakers. We typically have 40 and 30 amp, and occasionally something like a 20, or in one case a 5 amp breaker to power a Raspberry Pi. Only use specified fuses. There's a few fuses, one for the computer or Brio, and then one for, well, that's the main way. I'd probably use resettable breakers, or the circuit breakers, as much as you can. Fuses, once they burn, they're done, so that's not good during a robotics match. Um, Protect with the appropriate size circuit breaker. This just says like some of the different things that you can power and what the maximum circuit breaker you can put on it. So like some of the like the voltage regulator can only use a 20 amp circuit, and that's generally, oh, I could do 3 total of those. Okay, anyway, that tells you kind of what you can power in what level circuit. 622 is probably the most important one, well, important as far as just checking and making sure you're following it. It's about what the wire sizing is for different circuits. And so if it's 40 amp circuit, you have to use at least 12 gauge wire, or if it's a 30 amp circuit, you have to use at least 14 gauge. A 20 amp circuit has to use at least 18 gauge wire. Generally 12 gauge and 18 gauge are what we typically use for most of the wiring. Sometimes we tried to use 10 gauge wire instead of 12 gauge. I don't really believe that that's too important, but it's something that some teams try to go to a larger wire just to get less voltage drop and things. We use a larger wire for the power, the main power and everything right now. We have this year. Let's see also 22 gauge for certain things less than 5 amp, and then some other circuits like can be 24 or 26 signal level circuits, so like limit switches and things like that have to be at least 28 gauge. So anyway, that's a handy chart just to know which wires need to be which sizes. There's R623 is just appropriate connectors, and that just means that the connector needs to be rated for the wire size and for the circuit, and that you can't use mercury slip rings. R624 is that constant polarity wires, so any non-signal wires need to be color coded, red and black or some other combination, and then other than ones that already came with something. So in this case, like for a motor controller, the wire between the PDP and the motor controller has to be red and black, or some color combo like this. But after the controller, it's not constant polarity, so the outputs can be different colors. But anyway, it's helpful to keep your colors straight anyway. So don't modify critical power pass. This is that I think you can't use a custom circuit to change like the motor actuator and things like this. There's some anyway. If you do want to try to modify something, you have to read this carefully. 9.7 is controls and commands. So that was most of the power distribution. This says you control the robot with the Robrio. So there's this is more into some of the controls, but I'll kind of just skim through, and I won't read all of them. But I think there's signal light, there's the radio or wireless bridge that you can modify some things, but it's specified here, like moving jumpers or labeling devices, or for the most part, anything that seems reasonable is probably in here. But anything that changes the function too much isn't allowed. Don't connect motor outputs to the Robrio. I don't know. Some of this is that's mainly controlled. This is more into the data signals, like so. The pneumatic or the power distribution has to be connected to the CAN network, and you have to connect. You can't alter the CAN bus in some ways. So, and then it kind of is getting into pneumatic systems and things like this, which may be interesting. A lot of times electrical is also doing pneumatics because it's a lot of it's wiring and plumbing and things like this. And so that's generally a kind of rundown through the rules, particularly of the power distribution. I'll send you the link, and you can just go through and look and read if you want to. But that's one place I'd to start to understand how the robot wiring is all put together. So I'll leave it at that.